my friends. This is lecture 9 in the pre-calculus course, angle measure and coterminal angles. Let's see. Let's define some basic terminology. If we have a line, then it will be extended on both sides. So we call it line AB. Now, if we say line segment, it means only the portion between the 2 points A and B. So differentiate between line AB, line segment. Now the third one is a ray. Ray is like half a line. It starts at a fixed point A and it will go through B, it will go to infinity. So that's a ray. So please try to understand line AB, line segment AB, ray AB. Now, these are properties of some angles. To have an angle, we rotate the ray about its endpoint. So this is the vertex of this angle here, and this is the initial side. So we rotate it. This is the terminal side. So just to understand these two words here, initial side and terminal side. If we go counterclockwise, that's a positive angle. See, this is a positive. So it can be angle 30, 40, 50, 100, 200. It can be 300 like this. See, that's a positive angle. It can be in any quadrant. We have 4 quadrants. Now the negative angle, this is the initial side. If we go clockwise here, that's a negative angle. See, like minus 200, minus 50, minus 90, minus 300. Okay, angles are classified by their measures. So we can have an angle like this between 0 and 90. We call it acute angle. These examples like 83, 10 degrees, like 39. This one, we call it right angle, just 90 exactly. It will be right angle. Obtuse angle, angles between 90 and 180, like 133, 98, 105, etc. And this is angle 180, we call it straight angle. This is the initial side, and this is the terminal side. Now this slide is a review on the circle. Just to remind you that if you have a circle here, then there is a center in the circle, and there is a radius r, we call it just small r, and there's a diameter. Now the diameter here is 2r, so if you need r, you can divide by 2. If you need the area of the whole circle, it will be pi r squared. If you need the circumference, the distance around the circle, circumference, so we call it capital C, 2 pi r. Just review that. Now we can measure the angles by degrees or radians. Let me explain both. A degree usually denoted by small circle here. So we say 360 degrees. So a degree usually denoted by circle, this is a degree symbol, is the measurement of a plane angle in which one full rotation is 360 degrees. So the complete revolution, or we can call it full rotation, or we can call it one complete circle around, or we can call it one full cycle. All of these are 360. And we have seen some examples before. All right. Now the radian measure. Listen carefully here, the radian measure. 1 radian, if you understand 1 radian, you can understand the other angles. 1 radian is the angle, see this is theta here. 1 radian is the angle subtended, so faced at the center of a circle by an arc. See, this is an arc here. Length of this arc is r. So the arc, the length of the arc is equal to radius of the circle. So if it happens that this one is 3 centimeters and this one 3 centimeters, then this one is 1 radian. If this is 17 centimeters and this is also 17 centimeters, this will be 1 radian. So to know 1 radian, just make on the circle, length of the arc is equal to radius of the circle. Now, if we need complete revolution, which is complete cycle in radians, it will be 2 pi. Now, to show that, please wait until lecture number 10. I will show you in details how do we know the complete revolution in radians is 2 pi. Now, there is a conversion between degrees and radians. If we know 360 degrees is 2 pi radians, then we can divide by 2 and we will have 180 degrees is equal pi radians. So 1 degree, pi over 180. If you divide here by 180, this is 1 degree. So 1 degree will be approximately 0.01745. Very small, 1 degree. Now, if you need 1 radian, divide by pi. So it will be 180 over pi degrees. Now, if you divide that by calculator, you get 57.29. So almost 57 point something degrees is 1 radian. So 1 radian for sure is higher than 1 degree. Now to convert degrees to radians, multiply by pi over 180. To convert radians to degrees, multiply by 180 over pi. Let's see some examples. So we have 4 examples here in example 1. Convert the following angles to radians. We have 30 degrees and we have 270. So in the solution, we take 30 multiplied by pi over 180. Cancel the 0 here, divide by 3, so pi over 6 radians is exactly 30 degrees. For 270, the same thing, multiply by pi over 180, we cancel here. The 0, we divide by 9, so 3 pi over 2 radians is equal to 70 degrees. Some of these angles are special angles, and some are not special. Now, let's do the other way around. 2 pi over 15 radians, let's convert it to degrees. So to convert, we multiply by 180 over pi, cancel the pi, divide here by 15. You can break it down into 3 times 5, and then here you get 12 times 2 pi's, and the pi is cancelled for sure. So that's 24 degrees. Minus pi over 6, the same thing you do will be minus 30. Now, angles in standard position. So how do we know that angle is in standard position? There are 2 conditions here. You have to look at the vertex. It should be at the origin here. See the vertex here at the origin, this one at the origin. And then the initial side where the angle starts, it should be on the positive x-axis. So if we have an angle like this, see this one is a positive angle. If we have an angle, this is the initial, this is a negative angle, and that's the terminal side. So all of these, you can have more than 360, more than 2 pi. So all of these are in standard position. Central angle is the angle where the vertex is at the center of a circle. So we call this central angle. We have 4 quadrants. Just to remind you, 4 quadrants. We have quadrant number 1. Theta is between 0 and pi over 2. All the angles here are acute. Now this is theta pi over 2. This is theta 0. So easy. Quadrant 2. All the angles between pi over 2 and pi. Quadrant 3. Theta, the angles between pi and 3 pi over 2. This is 3 pi over 2 here is 270 degrees. Quadrant 4, all the angles between 3 pi over 2 and 2 pi. Now, some angles, we call them quadrantal angles. Quadrantal angles, so they lie on the x-axis or the y-axis, like 90 degrees, 180, 270, and so on. All these angles, we call them quadrantal angles. Supplementary and complementary angles. You can start with any one. Let's say complementary. Two positive angles, alpha and beta, are complementary if their sum is 90 degrees. So alpha plus beta is equal to 90. Then we can call them, they are complement of each other. So angles like 70 and 20 are complementary. Supplementary angles, two positive angles, alpha and beta, are supplementary if their sum is 180 degrees, like 133 and 47. Okay, example 2. Alpha is the complementary angle of 40 degrees and beta is the supplementary angle of 108. Let's find alpha plus beta in radians. See, in this question, we have to do three things. We have to find the complementary, we have to find the supplementary, we can add them, but these are degrees we have to convert, or you can convert each one separate. Let's see, alpha is the complementary angle of 40. So alpha 90 minus 40, 50 degrees. I can convert that to radians multiplied by pi over 180. So it will be 5 pi over 18. Now beta is the supplementary angle of 108. So 180 degrees minus 108 is 72. 72 times pi over 180. When you simplify, you get 2 pi over 5. Now you can add alpha and beta, 5 pi over 18 plus 2 pi over 5. You need here the LCD 90. So it will be 61 pi over 90. Coterminal angles. And this is really important. I said here, very important. Try to understand because you'll use this in many questions in trigonometry. Coterminal angles, they have the same initial side and the same terminal side, but different amount of rotation. So coterminal angles are angles, they are not the same numbers. Just an example here, I will explain in details. Angles 830 and 110, we call them coterminal. Now, how do we know? Take any angle x in degrees or radians, then you can find many coterminal angles. So if you take x in degrees, it will be x plus k times 360. K is an integer number. You know, integer number is like 1, 2, 3, 4, 5, or 0, or minus 1, minus 2, minus 3. There is no fraction in the k. So if I take 830 just as an example here, and we'll see many other examples, 830, this is a big angle, you see? No, this is big angle. How do you know big angle? More than 360. So let's subtract minus 360. So you get here 470. Still, this is a big angle. You subtract 360. See, that's the first example. That's why I'm going slowly like this. So you subtract 830 minus 360, you get 470, still more than 360. You subtract another 360 until you get an angle between 0 and 360. All right? So it can be in quadrant 1, 2, 3, or 4. Now 110 is in quadrant 2. See this one here. So 110 and 830 are coterminals. Now every angle has many coterminals because you can use this rule in degrees or this rule in radians. Let's see more examples to understand better. Find two positive and two negative angles coterminal to 50. So just imagine angle 50 in quadrant 1. If you need two positive angles coterminal, so we can take K1. See, I put 1 here, 1 times 360. 360 is complete revolution, remember, complete cycle, complete rotation. So 360 plus 50, 410. 410 and 50 are coterminals. If I take K is equal to 2, or I can take K3, K4, K5. All right. So if I take K2, I multiply 2 times 360, 720 plus 50. Now, two negative angles also, I can take -1, -2. I can take any integer number. K is integer here. Okay. So 50 minus 1 for the K multiplied by 360 minus 310. If you take K minus 2, multiply by 360 and then add 50, it will be minus 670. So all these four angles are coterminal to 50. Now let's see example number 4, the very important example. Find an angle between 0 and 360. So we need angle in quadrant 1, 2, 3, or 4. Coterminal to the angles 880 minus 822 pi over 3. Now, first we look at the angle. If it is bigger than 360, so we have to subtract here. You can subtract as many multiples of 360 as you like. If you have a small angle here, like less than 0, negative 800, you can add multiples of 360. And now I will show you what we do in number C. So 880 is big angle, so we have to subtract. You can subtract 360, 360 times 2, 360 times 3. So if we take K minus 2, that means every K1 is complete cycle. So minus 2 times 360 minus 720. So we subtract 880 minus 720. That would be 160. 160 is okay because it is between 0 and 360. So we say 880 is coterminal with angle 160. They both lie in quadrant 2. Now, if you look at minus 800, we have to add. So if you add 360, it will still be negative. If you add 720, it will be also negative. So we have to add 3 times the 360, which is 1080, 3 complete cycles, added to a minus 800, you get 280. So we say the angle minus 800 degrees is coterminal with 280. They both lie in quadrant 4. Now to find the coterminal with the angle 22 pi over 3, let me show you a nice easy method. We have to subtract multiples of 2 pi. How do you know that number? Just little check here, very quickly you can do. Just divide 22 over 3. You can do that in your mind. So that would be 7. See, this is the important number here. 7 times 3 is 21. 7 point something. So in this 7, you see how many complete cycles. If you take 7, it's not multiple of 2 pi, but if you take 6, that will be 2 pi times 3. So that's why I know now the number K will be minus 3. So minus because I have to subtract. 6 pi, 6 is less than 7, and it is multiple of 2 pi. So 22 pi over 3 minus 6 pi will be 4 pi over 3. Now this is an angle between 0 and 360. Why? Pi over 3 is 60 times 4. You see, pi over 3 is 60 times 4, 240. So this is angle in quadrant 3. So 22 pi over 3 is coterminal with the angle 4 pi over 3. And both they lie in quadrant 3. Now this is lecture number 9, angle measure. and coterminal angles. After that, we'll see lecture number 10, circular motion. At the end of lecture 10, please, you can find some old exams questions to practice on both lectures. Thank you for watching. If you like the video, you can subscribe and share it with your friends. Just to remind you, this is Pre-Calculus course, lecture number 9. I wish I can see you in another video with another topic. Thank you very much.